Now, good morning, ladies and gentlemen. Welcome to L2 Construction Series platform. Today is day 12. The topic for today is disruption cost claims in construction projects. Now, we're very happy to announce that as of now, this time, we have more than 410 participants who have successfully logged in. And as usual, the number will keep on increasing for the next 10 minutes or so. Now, today we have three special guests. First, we have Ms.Lynnda Lim, who is a senior partner from Contract Solutions I. She is a claim consultant who has more than 20 years of experience in the construction industry. Now, she will be our first presenter for today on this topic. After Lynnda has presented, we will also invite Michael Mclver, who is from Plus 3 Consultants, and who would then pass on to Alex, his colleague, Alex from Spain, the associated company called Construction Dynamic Solutions, to present the second presentation. Now, after which we will then pose questions to these three speakers today, and we will also invite audience to set out their questions if you have any for any of the presenter today. Now, without further ado, I'm going to invite Lynnda. Lynnda, are you here now, Lynnda?
Yes.
Okay, can you perhaps briefly introduce yourself to our audience? Then you can proceed to do your presentation.
Good morning, everybody. My name is Lynnda, Senior Partner of Contract Solutions I. I am a adjudicator, I'm an expert, arbitrator, mediator, and I'm doing also giving legal advice, contractual advice to the ongoing projects. Okay. So today's my topic is about the disruption cost claim in the construction projects. So what I'm going to do is I will take you through some of the general principle, before I move on to the method to quantify disruption cost claim in the construction industry. Next slide, please. So delay and disruption is actually comes together. Okay. But delay, it's different from disruption. Delay, it's basically delay to the completion works or completion dates, okay? Whereas disruptions, according to SCR protocol has provided the definitions, it is a disturbance, hindrances, or interruptions to a contractor's normal working methods, resulting in lower efficiency. So that means the disruption claims, it's basically a loss of profits claim, okay? Sorry, loss of productivity. So when we measured the loss of productivity, basically you need to measure the loss of productivity between the two productions rates, i.e. the input and the output. Therefore, you will be able to identify a reduction in the output of the construction resources, i.e. the labor and the plant. Disruption costs, which is loss of productivity claims, are a production-related claims. It is not a time-related claims, okay? And it is often said that it's very difficult to prove. Well, that is subject to what information and what records you have. Next slide, please. There are factors affecting productivity. The common factors are increased labor, additional gangs, track stacking, overtime, adverse weather, out of sequence of work, accelerations, change or variations. Next slide, please. Causes of the disruptions are by variable reasons. They are contractors' control and also employers' control reasons. Okay? Contractors' control reasons are basically non-compensable events because these disruptions are caused by the contractor's own problem, i.e. poor workmanship, inclement weather, poor supervision, the plant frequently break down, poor quality, and some damages material. Whereas employers' control reasons are basically compensable events. which is provided under the contract's provisions, such as late or reduced access, late or wrong or incomplete informations, variations, suspensions, or directly employed contractors by the employers. Next slide, please. As I've explained, there are two types of disruptions, compensable and non-compensable. Okay, so this link to the previous slides that I have just explained. Next slide, please. So when you establish a causation for the disruption, the very first important thing that you need to have is records. Okay, so you need to have a complete and full records recording how and when the disruption happens at the site. It's on the daily basis. Okay, and then you also need to have your planned productivity, and you need to have a good record as to your actual productivity. Okay, and you need to have a resources planning. Okay, the machinery and the labors, how you plan, so that you can study the resources planning against the actual productivity. Okay, and then second thing is that you need to basically segregate the cost records for the effect of disruptive events. In this part, it's difficult because it goes to how the cost was being recorded, i.e. how you record each bill, whether this bill is basically for this event or for this activity. So unless your site team is able to make a remark on the invoices or the delivery or this, otherwise your accounts will not be able to capture the cost accordingly. Okay? So where there is a segregated cost records is not available, then at the very least, you need to take out the extra cost which is not resulting from the disruptive event. That's why in establishing this part in terms of cost is very difficult. Okay, next slide, please. In order to assist in general how to identify there is a loss of efficiency. So the very first, very simplest way is that you look at your planned productivity. Okay, i.e. The example given on the screen is basically 16 hours per 100 meters squared. When you compare against the actual production, it's basically 32 hours per 100 meters squared. Okay, so it's the same type of work, but you are taking a longer time. So when you work out the differences in terms of calculations, mathematically, you will be able to see there's a loss of efficiency of 50%. Okay, next slides. So the previous slides was basically telling you very simple to establish disruption. Okay, in SCR Protocol 2017, they have actually tabulated two types of ways to demonstrate disruptions. You can see on the productivity-based methods, there are quite a numbers of methods that you can adopt. And whereas the cost-based is only two methods that you can do. We normally use the productivity base as a method to establish productivity. The topic that I will be speaking on is basically measure mount analysis, which is the first one, project specific study. So basically, we'll be talking about measure mounts, which is accepted by court. And subsequently, my learner friend will be talking on the system dynamics modeling as well, which is recently accepted as, by the court as well. Next slide, please. So what is measure mount approach? Okay, it is quite widely accepted by the court. What is the reason of the court accepting it as a method to demonstrate the loss of productivity? Okay, the main reason is basically the measure mounts study and investigates the actual production achieved, okay, during an unaffected period. This is called measure mount approach. Okay. So when you compare the production, right, you are comparing the actual production during an unaffected period, okay? And then you compare against with the production rate achieved during an affected period. The difference of it, that will be this loss of productivity, okay? Next slide, please. So as I said, the importance of having the measure mount method is basically you are studying the actual site productivity, actual. So you are telling the court, the tribunal, as to what was actually happened at the site. Therefore, you have the actual site productivity during an unimpacted period and also an impacted period. So you are not taking, comparing with the tender outputs, because tender is basically is a planned durations, it's a planned productivity, which is not relevant to the actual site. Okay, next slide, please. So this is one of the examples when you do a measure mount approach. Okay, the first item was basically non-disrupted period. You can see the line. Okay, the blue line without any dotted, the blue line, that shows the cumulative excavations over a period of time. Okay, then during the non-disrupted period, we have actually identified that the average progress, which is during the undisrupted period, the production of it. Okay, and then you compare against the disrupted period. Okay, you can see the line. The line is slightly different. Okay, the non-disrupted period, the line is actually going up. Okay, and then disrupted period are basically the line is actually slanting towards to the other side. So you are comparing the production between the non-disrupted with the disrupted period. Okay, you are taking an average of the productivity of these two periods and you quantify difference. Okay, that is the method of measurement. Next slide, please. Of course, when you come to measurement approach, there are some assumptions that need to be made. Okay, so the first assumption is that it must be a non-impacted or very least impacted period. Okay, so this is called a measurement approach. Okay, so you need to be able to make sure that the period that you have taken, so-called as a non-affected period, is not the productivity is not affected by any other reasons. Okay. So the second assumptions that you made is the length of the period should be significant compared to the impacted period. So significant means you at least take a period of 3 to 4 months, okay, for the comparison purposes. Okay? And the third assumptions that you made is there are sufficient contemporaneous project data for the analysis. Okay, so most of the physical units work completed, you must be periodically recorded, so that the cumulative labor hours can be plotted throughout the works. Okay, next slide. The fourth assumption is basically project data are assumed to be free of error. Okay, this all depends on how accurate is the records that has been recorded by the contractors. Okay, and then the last one, which is the most difficult one, assumptions, is that all disruptions during the impacted period are due to one's party, i.e. the owner's, the employer's fault. Okay. Any other factors unrelated to the claims are to be accounted or removed, i.e. others unrelated, meaning contractor's own delay. Okay, and any other reason which is not caused by the employer's default has to be removed. Okay, before you can make a measurement analysis. Next slide, please. So the attractions of the measurement are basically you are comparing actual as opposed to the estimates. Okay, so when you have the actual performance at site, okay, you are basically analyzing what was actually happened at site, but not a theoretical analysis. Next slide, please. This is one of the examples, real case. Okay? So where we have identified again, this is about the rock blasting issues, excavation as well. So we have plotted the blue line, the cumulative work done over a period of time, the entire construction period. Okay? You can see the table bottom, okay, and was highlighted in pink, affected period. Okay, you can see at the remark column, at that particular period, it was affected by some other delay events. Okay? That means before we can reproduce this chart, we have actually prepared a delay analysis in advance. So with that, we have already sort of identified the cause and effect as to the delay events. Okay, and then the next step is we moved on to calculate and to investigate, was there any loss of productivity issues resulting from this delay event. Okay, next slide. Then you can see the table bottom, non-affected and affected area, the period. The non-affected, basically, they are calculating from valuation, meaning 1 to 5, and then a cumulative of all this non-affected period. it gives a 44 per week, 44 meters square per week of the work done in production. As opposed to the affected period, you will see the productivity rates are basically 15 cubic meter per week. So you can see the difference. There is a loss in productions. Okay, next slide. Next slide, please. Okay. So therefore, you basically convert, and you basically in this case we are converting the affected loss of productivity into the delay. Okay, into the delay. Okay. So when you need to quantify the loss of productivity, you need to be able to work out the difference. So we have already got the difference: 44 versus 14 in terms of the production rates. So the difference of it will be your loss of productivity claims. Okay, next slide, please. Other than the previous one, the simplest way to do measure amount is basically you plot your percentage of work done, okay, based on the durations, okay, and then you extrapolate the control period to a straight line, okay, then you will be able to see, okay, and identify the period of inefficiency, which is from month of March to August, okay. From that period, then you went in to investigate further, okay, the reasons behind all it can be done. It depends on how you monitor the loss of productivity issues, okay. That's one of the way as well. Next slide, please. The other way, it's basically using S-curve. I'm sure when you do progress reports, when you do monthly progress report or whatever, you will be able to see the progress S-curve like this. The S-curve as to the actual and also the plan, okay? So if the actual one departed from the plan, okay, you will be able to see there are some issues about payment. There are issues about work that has been delayed. You identified the period, and then you go back to your contemporaneous records. You investigate, okay, what was the issues happen, why there is a disruption or delay happens at that particular point in time, okay? So from there, you actually work out the basis, and then you try to analyze whether there is a loss of productivity. Okay? So S-curve is a useful tool for you to identify whether there is disruption or delay happens during the projects. Okay, but most of the time the contractors will tell us that, you know, I know this excavation, okay, I have not been delayed, but because of there are certain circumstances that my work has been disrupted, I have suffered loss in production, loss of productivity. Therefore, the contractors usually will identify for you, okay, these are the issues, these are the problems that I encountered. Okay, that makes the life easier, that you can straight away jump in and do the analysis. Okay, so that is one way of it. You are getting information from the project directors or project manager who has the first-hand information. Okay, next slide, please. So when you investigate the curve and all this, when you see the curve is not the straight curve, or the curve is actually a normal, that is where you need to focus and see, is that a data issue, or is that a real disruption, or is there any other reasons? Because if you chart the line would not be abnormal like this. Okay, this is basically a trigger point for you, a warning bell for you to say that, hey, look, this is something wrong with information, or there could be a possible disruptions happen in between. Okay? That actually triggers you to do further investigation. Next slide, please. Okay. One of the way that you can quantify the disruption is by way of this daily disruption schedule. Okay. So basically, there is a table, prep, instruction, what of the work has been affected, the manner, correspondence, and then you can quantify the additional hours of the labors that you've incurred resulting from that particular instruction, and then the hourly rate, additional plants, and then your weekly rate and whatsoever rates that people that involved in that particular instruction. And then you sum up, and then you can get a total cost of disruption. Okay, that is also one of the way. I am not saying that this is not workable. At least this is something to assist contractors to come up with something, okay, at the very beginning. And then from then on, you can actually quantify further in the very detailed and micro manners. Next slide, please. So in gist, in order to succeed in your disruption cost claim, first and foremost, you need to have a very good records. Okay, you need to have a records where you records daily in details, especially your site daily records, that you need to record what was actually being disrupted, what are the area, which part of it, and then your invoice when you have received, you have to be identify it clearly. Okay, what is this cost for? Okay, and then as planned labor estimations, you need to have that piece of information so that you can make some comparisons. And then you need to be able to identify actual hours and costs expended on that particular projects. Okay, and then you need to identify the labor cost overruns to the highest levels to allow the losses to be attributed to a specific incident or delay. And then according to SCR protocol, it is advised that to perform a delay analysis to support the disruption claims. So there is a double layer of the demonstration as to the cause and effect. So that is basically some advices that I can provide to the participants, because to success in the disruption cost claim, it's case-to-case basis. It depends on how details that you can explain the work has been disrupted. Okay, with that information, then you will be able to work out something and demonstrate your disruption. Like this. Okay, that's all from me. Thank you very much.
Thank you, Linda, for the succinct presentation. And now I will invite the next presenter. But before that, I would like to pass the mic to Michael Mclver, who is the principal of +3 Consultants, who has 40 years of experience as a claim consultant, who has set up a +3 consultancy company in 1993 in Malaysia, who has a presence of about 27 years in Malaysia already. I'm sure a lot of people who are involved in the construction industry would know who +3 is. Now, Mike, I will over to you, yeah, so that you can also introduce Alex, who will be presenting the slides today.
Thanks, Loon. Hello, everybody. Yes, +3 have been in Malaysia in the construction industry for 27 years. And just to make sure we're not going stale in our old age, I'm happy to announce this week the +3 partnership with Quantum Global Solutions and CCR. So the 3 companies are going to operate under the name +3 in Asia and globally. We have offices now from the United States through Europe, the Middle East, Asia, Australia and New Zealand. So that's a combined total of around 200 consultants. And they're bringing to the party new services and technology, which is where we come to the next speaker, which is Alex Voigt from Construction Dynamic Solutions, who specializes in the system dynamics calculation of disruption costs, which were mentioned by Linda earlier and are accepted in the SCL protocol. Now this, I think, is new to Malaysia, and Alex will explain to you the advantages of this system dynamics. Thank you. Over to you, Alex.
Yes, thank you, Michael. Thank you very much. It's a pleasure to be here this morning. So I wanted to introduce you to system dynamics because even though it's been around for a while, it's still not in the mainstream of construction. So I'll pick up where Linda left it, and we'll move on from there. And next slide, please. Because, of course, everything that Linda said is true, and there are methods that work very well for disruption, like the measured mile, but they're not always applicable, and especially when you're dealing with the bigger projects with many disruptive events. Historically, well, the recovery rates on disruption claims have been rather low, 5–10% maybe. So they have not been very successful. Now, we believe that with system dynamics, the picture changes quite radically, and that's what we will be showing you today, so that at the end of this presentation, maybe you can judge by yourselves. But before I launch into describing this method, first I still need to take a look at the dynamic nature of disruption, and you'll see why in a second. Next slide, please. Now, as Linda mentioned, disruption comes from losses in efficiency, losses in productivity. And there are many factors that can cause that. And I'll walk us through an example where I'll use just the 4 that you can see here to keep it simple. So to look at the nature of disruption, how it arises on projects, how it spreads, let's start by looking at how projects are actually executed, how they work. So next slide, please. At a very basic level, you have a given amount of scope that you need to work on. The work, then you apply manpower. That manpower works at a given productivity rate. The work gets executed, it's done, it's completed. And of course, you adjust your manpower levels as you move along based on your planned sequence of the works. So you always keep an efficient level of manpower. So far, very simple. Everything is fine. Next slide, please. But let's assume that then something happens. For example, there is a design change. And now it's when it begins to get interesting. Because, for example, the design change may cause a slight increase in the scope of work. So now suddenly you're lagging behind a little bit because you're not as far ahead as you were hoping to be. And of course, especially if this design change is late, then if you find yourselves in construction, you may suddenly not have all the shop drawings that you would have liked to have at this point. So you have to change your plans. And of course, this is inefficient. So here comes disruption, right? But this is just the beginning of the story. So next slide, please. Because now that you're falling behind, you have to do something about it usually. There are usually severe penalties if you deliver a project late. So you have to accelerate. And there are different measures you can take. The easiest, most simple one is probably just to apply schedule pressure on the crews. Tell them to work harder, work faster, which can work, at least for a while, until crews get used to the pressure. So let's assume that it does work, and then people actually do speed up. So you actually have a little bit of negative disruption. You're becoming more efficient, at least for a little while, and you may be able to make up for some of the delay that you suffered. But something else happens. Next slide, please. And this is something that I probably should have mentioned before, because even though traditionally we say that disruption comes from losses in productivity, that's mostly true, but it also comes from when you have to do additional rework. And this is what happens when, for example, well, first of all, no contractor is ever perfect. Obviously, nobody is. There are always some mistakes that are made, and therefore some amount of rework is always done on projects. That's cannot be avoided. It's unavoidable. But when you apply schedule pressure, well, people start cutting corners. So there are more mistakes being made. And of course, this is not done on purpose at all. So the mistakes are hidden. Nobody knows they're there, and they stay hidden for days, weeks, months, sometimes even years on very large projects, until eventually the mistakes are found and are corrected. The rework is executed, which requires additional resources, and that's why it causes disruption. So next slide, please. But if we look at this from the project manager's perspective, so we had this design event, a change, and now let's say 2 months later, suddenly we have this wall of rework coming our way. And of course, nobody remembers the design change anymore because so many things happen in between, right? Things happen on a daily basis. Who remembers that design change? Now you're facing this huge amount of rework, maybe, and well, you have to fix the problem. So maybe then you decide to just throw people at the project. So you start working out of sequence because the sequence cannot accommodate all these people, but still that's inefficient. But you hope that by just the sheer number of people, then you will be able to make additional progress at the expense of additional disruption. But then, of course, maybe some of the new people that you are hiring, they may not be as skilled or as experienced as the ones you had from the beginning. So then they're less efficient. So there's a little bit of disruption coming from that as well. So you can see where the story is going. We'll stop here. But you can see that from an event that happened at one point in time, now you have consequences that lead to additional consequences that keep going and rippling through the project all the way till the end. And not only that, but the disruption also spreads laterally because, well, let's look at the people you put on and that had to work out of sequence. Well, some of them may have been working on the amount of scope affected by the change, but many will have been working in other places. And the new people that was hired, was to say where they will be working, right? So this is why disruption is so difficult to assess and why it is so perverse. Because events happen today, the consequences spread out in time and all over the project. And so far, we've just looked at one change. Of course, while all this goes on, please, next slide, please, changes keep happening. And you have one, and then you have another one, and then you have another one. And this is from an actual disruption claim that we worked on, where during just 1 year of the project, you had 750 design changes proposed by the employer, 250 of which were actually implemented. But even those that were not implemented, that were just considered, were disruptive because they forced the contractor to wall off given areas of the works, waiting for the employer's decision. So all of these proposed changes were disruptive. So if you're now trying to assess the disruption and who was responsible for what, you have all these moving parts, everything influencing everything else. So how do you keep track of what's going on and who's responsible for what? Next slide, please. Well, we cannot do this in our own minds, but thankfully we don't have to, because we can just take this causal framework that I just walked us through, and you can translate the words that I just spoke into mathematical equations. And thus we can build a computer simulation model that can keep track of all these different moving parts and how one part affects the another and how some consequences have other consequences and so on and so forth, because that's what computers are good at keeping track of things. And this is the essence of system dynamics. Next slide, please. Before I explain how it works, just a little bit of historical background. System dynamics is a computer-based simulation method. It was developed at MIT in the early 60s, and it was first applied to a disruption claim in around 1980. It was a claim against the US Navy. Since then, it has been used in hundreds of projects to help manage them better all over the world in all kinds of industries: the automotive, construction, engineering, oil and gas, shipbuilding, IT development, you name it. And that we know of, there have also been about 40, probably 45 now, major disruption claims worldwide, with total disruption claim values at the order of about $20 billion cumulatively. That we know of, because obviously most of the data is confidential, so it's difficult to know for sure. Now, in 2009, a tool developed for the Fluor Corporation based on system dynamics was named Industry Best Practice by the Engineering Construction Risk Institute. And more recently, in 2017, the Society of Construction Law added system dynamics to the second edition of its delay and disruption protocol. So it's taken 40 years, but system dynamics is now making major inroads into the construction world. Next slide, please. And now I would like to explain how it works, how we do it. Well, as I said, the framework that I walked you through, that explains how productivity gets affected and how disruption arises on projects, has been around, as I said, since around 1980, so for the last 40 years. It has been used on hundreds of projects, so this causal framework that I described has been fully validated, because again, it has been proven to be accurate in all kinds of industries all over the world. So the way we assess disruption on a new project, we take this framework, translate it into equations, and then we look at all the key data of a project. The project, about how it was planned, the baseline schedule, right? The BOQ, then how it was actually executed, the daily sheet showing resource usage, the S-curves, and of course, also all the data relative to the disruptive events. There was a design change and there was scope addition. Well, how much scope was added and when was it added, and so on and so forth. So that at the end of the day, what we end up with is a simulation model that reproduces the actual performance of the project. And you can see here on the right, this would be a plot that shows manpower over time. The x-axis would be time. So the dashed red line would be the data, the actual data for the project, and the straight blue line would be the result of the simulation. And next slide, please. You can see that then the system dynamic simulation model produces a simulation that accurately reflects what happened on the project. So it's the most accurate, the most complete, thorough, consistent, and plausible explanation of what actually happened on the project. And it does not contradict any of the available information, which of course is a very nice thing to have, but it still doesn't answer our question, yes, but how much of this was the responsibility of the employer? But now we can answer that question. Next slide. Because since we have a simulation model of the project, what we can do now is we can just remove those disruptive events by the employer. For example, if there were design changes that added scope, we set that additional scope to 0. If, for example, the engineer reviewed the shop drawings too late, we set that to be so that the drawings are reviewed on time in the simulation. And leave everything else the same. Don't change anything else. The characteristics of the project, the characteristics of the labor force, the management strategy, everything else stays the same. And you simply remove the events, press the simulation button again. And next slide, please. And then you end up with what we call the but-for simulation, which shows what would have happened if those disruptive events by the employer had never occurred. Never happened. And now we can answer the question then, how much did the employer disrupt this project? Because if you look at the top right corner here, the blue line, the as-built simulation, and the red line, which is, you can hardly see it, but it's underneath, they show how many hours, for example, direct man hours were spent on this project. And the green line shows how many would have spent if there had been no disruptive events by the employer. So clearly the difference between the two is the responsibility of the employer. And that is then the basis for our claim. Of course, that also includes direct costs of variations, but when you remove those, what is left is the disruption for which the employer is responsible. So next slide, please. So this is how we use system dynamics on complex projects. Again, it's not a crystal ball, but it can do these three things very well. Because it's based on a causal framework, it can very accurately and nicely describe the causal link between the disruptive events and the damages that were caused by them. And because we use a computer, we can also very accurately estimate the damages that were caused, because we can keep track of all those consequences of the consequences of the consequences that I mentioned earlier. And we can also keep separate the consequences of the events for which the employer was responsible and the consequences for which the contractor himself was responsible. And finally, also, since we're dealing with a mathematical model, of course, it's testable and you can measure its accuracy and its level of uncertainty as well. So you can come up with confidence ranges for the results, which is something that courts are insisting more and more. And just to conclude, all of this, of course, sounds theoretical. So I wanted to leave you, next slide, please, with an actual example. And this is a claim that we worked on. It was a design, bid, build development, commercial development in the Middle East, about a $1 billion project. It severely overran both in cost and in time. And they tried to apply the measured mile, but actually that example with the 750 changes, that was from this project. So there was no clean mile anywhere on this project. So they tried it, wouldn't work. So eventually they turned to system dynamics. And we were able to run the analysis I just described, which determined that about 60% of the overrun had been caused by the employer. There was no settlement. The thing was eventually settled in international arbitration, where the three-judge tribunal agreed with our presentation and awarded actually 100% of the disruption being claimed to the contractor. And this is all I have time today. This is all I wanted to let you know. So thank you very much. And I look forward to your questions.
外聘那边那个 market， 其实很多时候，每个
presentation, and I'm sure the audience was able to benefit a lot. For those who don't know, Alex is now physically in Barcelona. His local time there is now 5+ a.m. in the morning. We really appreciate you being able to join us despite the time difference. Now, I have a few questions, and I would like to ask Lynnda first. Lynnda?
Yes.
Okay. Great presentation from you as well. It is clear and concise. Okay. So my question is this. What is the difference between disruption claim and loss and expense claim? Does disruption not cause a delay and a delay not cause a disruption? They sound so similar in concept to each other.
Yes. Both of them are actually intertwined. So basically, when you talk about disruption claims in the context of loss of productivity, that is basically a production claim. You are working out the difference of the productivity. Okay, you are putting it as a production, a work-related claim. Okay, whereas loss and expense claim are basically a time-related claims, where you have been prolonged for a certain period of time. You are quantifying based on the durations, the prolonged durations. That is the difference between the disruption and the loss and expense. Okay, so as you say, it's actually intertwined. There are few ways that you can look into the disruption claims in different ways. Okay, so not necessarily disruption claims not causing any delays to the work. Yes, it does in fact, because delay and disruption are basically in the same terminal, same word itself. Basically, it says that if you can demonstrate the delay and the disruption, yes, you are entitled to so-called loss and expense. But if you are demonstrating the disruption in the context of loss of productivity, then it's a work-related claim. Okay.
Okay, thank you, Lynnda.
Yeah.
Lynnda, you told us that, as we also know, disruption cost claim is not easy to prove. You mentioned good records are required for the preparation of the disruption cost claim, which I can't agree more. Perhaps you can elaborate further to the audience what records are required to make a good disruption cost claim.
The very simplest and the straightforward record is site daily records, i.e., every day the site team will have to fill in how many machineries, the weather, what is the weather of today, and then some description as to the work. If the project managers at that point in time realize that there will be some productivity issues, and then all this information as to how many workers working at the site, for what particular items, for what particular activity, that has to be recorded properly. Okay? So on the contractual team part, basically you need to explain how and why this disruption, how does it cause and delay the work. So basically you need to do a very detailed narrative and explain the head and tail and how and when the disruption happens and which activity was actually affected, which floor, which levels, which team. Perhaps you have five teams at the site. It's only one team that has been affected. You need to be able to identify which team, how many people. It's as detailed as possible. Okay. That's my answer.
Okay. Lynnda, also disruption cost is not commonly drafted into the standard form of contract used in the Malaysia scene. So if a contract does not specifically provide for disruption cost claim, can we make the claim under loss and expense provision?
The simple answer to your question is yes. Okay. So as I said, the loss and the disruption basically it delays the work. Okay. So not necessarily it's a loss of production claim. Okay. But if you can basically demonstrate that the disruption basically causing the works to be delayed, prolonged, then you have a good claim as to the loss and expense. Okay, but if you have claim loss of productivity claim, then you cannot make the same again in the loss and expense the same claim, because it's actually overlapping. So you need to distinguish both of them. Okay,
yes, Linda. In addition to that, I think also to claim disruption cost under loss and expense is also very much depends on the language used on the loss and expense provision, right?
Yeah, it's true. It's true. It's very much on the languages, but also depends how you demonstrate your disruption.
Okay. Yeah, it's the way that how you're going to prepare the claim.
Yes,
and
it depends on your
the
records.
perspective you are coming in from. Yeah, okay.
Yes, and the record as well. How does the disruption happens?
Okay, okay. So there's no singular
basis,
formula to do that. Linda, okay, I'm sure you have handled disruption cost claim before.
Yes, yes.
Yeah. Can you share with us your successful experience about it?
My first successful experience was basically the very first Ampang line projects, where the contractors basically suffered because it's a linear construction. It's linear. It's not a area. So when it's linear, it's very easy to establish. But when you have these piers is not established, not able to work, then you need to move to next few piers. So from there, basically, I think they are quite experienced foundation contractors. So they will have already have a team to work on this. So there's a lady QS, which is very comprehensive. She had all these site daily records. She went to the site and prepared everything. And she used that daily disruption schedule to work out the total cost of disruption. And eventually the employer actually looking at the information and also the correspondences contemporaneously recorded, and they allowed the cost for disruption. So as I said, there is no specific rules to adopt or to demonstrate. As long as on balance of probabilities, you are able to demonstrate that you have been disrupted and you have been suffered loss of productivity as a result of the instruction change in design or whatsoever, then there is a grounds for you to claim disruption claims on that basis.
Of course, Linda. That's all from me. I will now pass the mic to my host partner, Wai Loon. Wai Loon, please.
Oh, all right. Thank you, Hong Kit, and thank you, Linda. Alex, I will be asking you some of the questions, after listening to your presentation. Well, you have actually, in your last slide, mentioned that you were involved in a project called the Tuxedo Park in the Middle East, and you have made a claim for disruption costs, and it was eventually went into international arbitration, in which you have won 100% of the claim for disruption using the dynamic analysis, dynamic disruption analysis method. Now, I'm just wondering, this is kind of new to the Malaysian scene, and I would like to hear from you. Would it be more complex to come out with an analysis using this dynamic disruption analysis compared to the traditional or recognized methodology?
Okay, that's a very good question, actually. And let's see, system dynamics is more complex than the other methodologies to be used for disruption, for example, the measured mile. So if you could use the measured mile, you should always go with it because it's very straightforward and people know it, it's widely accepted. It's just that, as Linda also pointed out, it works well in some situations, like very linear projects. For bigger, more complex projects, more horizontal ones, sometimes it doesn't work. So for those situations, really, there is not much of an option. And so the question is, will a tribunal, a court, or just your opponent accept the validity of a system dynamics analysis? Of course, you can never be 100% certain, but what we can say is that the criteria for admissibility, the requirements, are pretty much the same through all jurisdictions. The wording may change here a little bit, there a little bit, but they're pretty much the same. And system dynamics fulfills all of them. And it has been used as, well, we're now using it in the Middle East, but it has been used in America, in the United States, it has been used in Europe. We're now trying to move also to Southeast Asia, but so far, because it's a scientifically based method, it's taught at universities, it's widely recognized, there are scientific magazines, journals, so there really is no hurdle for admissibility. Even if people don't know it, that doesn't mean that it should not be accepted.
Understand. Now, you see, the Malaysian culture might be a little bit different from that of the Western side, where you tend to find, if you here in Malaysia, a lot of the people, especially contractors, do not keep good records. Just assuming, I think it's quite normal as well. Not all projects you have 100% good records for you to do the simulation, right? Now, assuming that we have a 60% of records of what actually happened in relation to the disruption claims, would dynamic disruption analysis system still be usable?
Yes, and that is also something that's usually the first or the second question we get when we are talking to a potential to a contractor that is considering the use of system dynamics, because the data is never perfect. It's not particular to Malaysia or Southeast Asia. That's something you find everywhere. And so we always work with the assumption that the data will not be perfect, and it doesn't have to be perfect. There are some elements that you need to have. You need, for example, you need to have records on manpower if you mean to claim for manpower costs. But that doesn't just affect system dynamics, that affects all methods. You're supposed to be able to prove what damages you suffered, and that's how much cost you had. So
have been ordered by the government. In Malaysia, we have the movement control order. We basically, construction is not an essential service, and therefore all the construction works have to come to a halt unless it is a critical works. Now, we predict that even if the MCO is lifted eventually, the working patterns will be very much restricted because a certain procedure on hygiene standards and also social distancing will need to be complied with as well. And it is not really the business as usual, as on site, the working methods might be changed as well. Now, that would be disruptions, right? And it was not contemplated when the parties entered the contract. Assuming that disruption claim can be claimed arising from that kind of situation after the MCO is lifted. Now, what kind of data would you recommend for the contractors in Malaysia to gather, for this dynamic analysis to be used to support their claim later?
Well, the basics really are always the same. First of all, absolutely necessary, you need to record the costs incurred. So the man hours spent, the cost of equipment that you used, and all these sort of things. Then second, you would need to be able to document the progress that has been achieved. So for example, the S-curves are critical. Once you have those, that means you have the basics covered. Then of course, the other thing you need to be able to quantify the disruptive events that you suffered. As I mentioned in my presentation, if there were design changes, you need to be able to quantify them in the sense of how much scope was added, how many drawings were changed, that sort of thing. And if there are no records, no precise records for them, then at least we need to be able to work with somewhat precise estimates. But as I said, that's the same kind of thing that we find on pretty much any project all over the world. Now, with this this virus, really, it's different in the sense that there may be before and after kind of situation. So there may be the baseline productivity of the workforce in a project may be different before the event and after the event, just because methods, processes are different. But that actually is handled by our method, so almost automatically. So the causal framework that we use takes care of that. So we would not need additional information for it.
Thank you, Alex. We have a question from the floor. Now, he said he's a Malaysian QS based in Canada. Now, from your experience and disruption claims you have been involved in, how would this dynamic system aid in claims against big oil and gas companies as opposed to the usual claim methodology?
Well, I think I'm going through the claims that have been brought so far. I know it has been used in at least one claim against a big oil and gas company. And a few, well, one big oil company and also against a gas company, 2 or 3 projects. And they did not make it all the way through arbitration, so we don't know what a tribunal would have ruled, but they were settled, and they were settled favorably to the contractor. So I would say that, yes, it works pretty well. But again, that's my experience.
Okay. Now, Linda, I would like to pose the same question to you, but in a different way. This also a question from the floor as well. Now, as you know that we are going through this MCO period, and after the MCO is lifted, there would not be the same, in the sense that you cannot work in a way as in pre MCO period. So there would be bound to be disruption. And how do you actually deal with disruption arising from the new norm that is expected to be implemented?
I think to start off with is that, as you say, it's a new norm, which is not beyond which is beyond the parties' contemplation. Nobody expected that to happen, you see. And also in terms of Malaysian law to deal with it, that is also unclear. Okay, so at first, what the contractors can do is basically you do your part and you tabulate and you quantify your disruption cost as much as you can. Okay. Then, of course, it's also at the mercy of the employer. Some employer are good enough or kind enough to say, oh, I will compensate you as ex gratia payment, for example. Okay, so if they alternatively, in the event that you are going for a dispute resolutions, and these informations of the disruption during the MCO will be raised in one of the issues in the arbitration dispute resolution, and the tribunal will have to decide on that point. Because when it happens as resulting from the force majeure, it could be resulting from a neutral event. Because when it happens as a neutral event, in contract basically and in common law basically says that neutral event you will be entitled to time. But in terms of cost, that is not allowable, you see. But under that circumstances, the contractor would be can also distinguish the difficulties, and then from there you can establish the liability for the payment as well. This is my view. I'm not too sure how we would be actually dealing with that, knowing that this is a new situation. You see, because our act itself doesn't say anything about how to deal with circumstances like this. Okay. Yeah.
Okay. I think depending on the terms of the contract, of course, if you claim it under the force majeure, loss and expense would not actually be allowed because it's a neutral event. But if it interrupts the order of works and perhaps the workings, restricting the working space as well, that could constitute a variation. Well, would then claim disruption costs arising from variation. Now, as I said, that would actually depends on the terms of each contract, whether a claim in such a situation would be allowable. Now, I think we have overran again this session for about 15 minutes, and I would like to thank both the presenters, Alex and Linda, for their succinct and precise and comprehensive presentation. We have learned something new. New technology or software methodology has been introduced by Alex to our region. And before we close the session, perhaps I invite Mike, Alex, and Linda to perhaps give a closing remark to our audience today. Can we start with Lynnda?
I think one advice for me as a closing remark is keep good records. When you have good records, you can have options to demonstrate your loss of productivity whichever way you want. If you don't have a record, then you don't need to talk about this. Thank you.
Alex?
Yes, thank you. I actually agree with Lynnda, and it's much less costly to prevent disruption than actually have to claim later for it. So yes, if you can keep good records and try and avoid it, that's always the best solution. If not, then you'll have to use a measured mile or system dynamics, and it'll always be more expensive.
All right. Michael, do you have anything to say to our audience today? Michael? All right. I think Michael is not with us now at the moment.
Microphone.
Oh, microphone issue.
Yeah.
Okay. All right. Okay.
Yeah.
Do you have
Thanks. Yeah, I've been muted the whole time. Very good presentations all round. I think, the system dynamics is something new to Malaysia, and I've seen a few comments on the chat line to say, is it too sophisticated? Is it too much for Malaysians? But it's not. I think one of the beauties of it is because it's a mathematical model of the project, it can cope and overcome gaps in the data. So where we haven't got enough complete and perfect data, the mathematical model can bridge that, and it can demonstrate an overall plausible story without 100% of the records. That's correct, Alex?
Yes, and that's actually true. And because when you're claiming for disruption, you don't have to be accurate beyond a reasonable doubt. It has to be just the most likely answer, right? It has to be plausible,
Yes.
and your answer just has to be better than the opponent's. And
yeah, and when
can do that.
When you plot your S-curves on the data that is available, it's tested by Monte Carlo theory, isn't it? So you do hundreds of thousands of simulations and get the most accurate one you can.
Yes, well, you build your model, and then usually you get the question of, well, couldn't you have built a different model that could have come up with a different answer? And that's when we use Monte Carlo. So we run hundreds of thousands of simulations to look at the confidence range around the results. So we can say maybe the claim was 50 million. With 90% confidence, well, maybe it was 90 million plus minus, let's say, 13%, for example.
Yes.
All right. Thank you, Lynnda. Thank you, Alex. Thank you, Mike, for sharing this useful information and various techniques with us today. We all know by now that disruption is when a contractor has performed differently or less efficiently than originally planned. And disruption can occur even if the project is completed on time. So when contractors have to work twice as hard to reach the same result, they should be able to get paid. Although quite difficult to prove, as Lynnda said, disruption claim can be a useful option when the impacting event doesn't quite reach the level of delay or require an extension of time claim. So the best way to set up yourself to a successful disruption case is to, as everyone agrees, document everything. The more supporting evidence you can provide, the more likely you will get compensated for the additional cost incurred. So this, of course, very much depends on what your contract says. So, okay, thank you, everyone. If your questions have not been addressed today, don't worry. I repeat again, we will address the pertinent questions at our Q&A only section on the theme. Right, tomorrow we will have Dr. Nasim joining us from New Zealand. Dr. Nasim is a Malaysian but has been exported to New Zealand, one of the finest Malaysian exports. He's now an associate professor and a director of internationalization at Massey University in New Zealand. And like us, fellow Malaysian, he is also currently in lockdown in New Zealand. Tomorrow's topic is, let me see, plain language construction contract, which I assure you will be an interesting one with a lot of takeaways. So thank you, everyone. Enjoy the rest of your day.
Thank you.
All right. Thank you to Lynnda,
Thanks.
Alex, and Mike.
Thank you.
Thank you, Alex. Thank you, Lynnda. Thank you, Mike.
Especially.
Thank you, Wylon. See you again.
Thank you. All right.